Hi guys, today's video is all about matrices. I think this is going to be a great video for you if you're currently in Algebra 2 and planning on taking the ACT. A lot of school districts don't cover matrices in their Algebra 2 curriculum, but the ACT expects that you've seen matrices before. So, knowing how to add, subtract, and multiply matrices is going to earn you at least 1 point on the ACT, and it could be up to 3 questions on the math portion of the ACT. So follow along if you want to get sort of free points, because using matrices is not that hard once you understand the definition and how to use them. So first, let's take a look at that definition. A matrix is a set of numbers arranged by rows and columns, and it just forms a rectangle. So if you've ever worked with a spreadsheet before and you know what rows and columns are, you're pretty much set. Let me show you an example. This matrix has a top row and a bottom row, so we call the top row row 1. The bottom row is obviously row 2. And then if you look left and right, you're going to see 3 columns. So if we were to pick row 1 and column 2, that would be the location of a cell, and in that cell is just the letter B. So that's how you look at an individual matrix and individual numbers within a matrix. One of the things that's fundamental to figuring out how to work with matrices is considering size. So size is defined as the number of rows by the number of columns. Let me show you what I mean. So here's the first example. It's just like the other example I showed you with the letters, but this one has numbers now. This has 2 rows and 3 columns, so we're calling that a 2x3 matrix. The second example has 2 rows and 2 columns, so that's a 2x2 matrix. It's also called a square matrix. The last one has 3 rows and 1 column, so that's a 3x1 matrix. You're gonna see in the last 2 examples how size is really important when you're working with matrix multiplication. But first, we're gonna look at a problem involving matrix addition. With matrix addition or subtraction, you just need to make sure that each of your matrices is the same size. So on this problem, we have the first matrix is 2 rows by 2 columns. The second matrix is also 2 rows by 2 columns. So that's good because we want to just look at each individual cell and add them together. So matrix addition, as long as you have a little bit of practice doing it, is actually quite easy. So for this problem, all we need to do is kind of compare each of the cells that are similar in each matrix and add them together. So our answer, I'm going to write our answer in red, is also going to be a 2x2 matrix. Okay, so for the first cell, this is going to be row 1 and column 1. We're just going to look at row 1, column 1 of the first matrix and row 1, column 1 of the second matrix and add those together. So let me maybe enlarge my answer. So our first row 1, column 1 is going to be 5 plus -6. Okay. And then let me just do different colors here. So row 1, column 2 is going to be 7 plus 3. Row 2, moving on to row 2, column 1 is going to be -4 plus 6. And I'll go to white. Row 2, column 2 in each of these is going to be 4 plus 8. So then just perform those additions in each one, and you get 5 plus -6, that's -1. 7 plus 3 is 10. -4 plus 6 is a +2. And 4 plus 8 is 12. That should be our answer. So looking at our answer choices, looks like F is the correct answer. The second and third examples in this video involve matrix multiplication. So I think before I dive into those two problems, I'm going to give you a mini lesson on how to multiply matrices. Let's take a look. For our mini lesson today, I'm going to show you the process of multiplying two matrices together. So in order to be able to multiply two matrices, you first need to be sure that you can. And so we're going to take a look at one that's possible, and I'm going to show you why it's possible. So we're just going to do the 1 by 3 matrix you see there, 3, -2, and 7, and multiply it by this 3 by 2 matrix that you see here. The reason we are able to do this is because let's look at the sizes of these matrices. So this matrix is 1 row by 3 columns. So this is a 1 by 3. And this matrix here is a 3 row by 2 column matrix, 3 by 2. So as long as these numbers are equal, you are allowed to multiply them together. If they aren't equal, you won't get a product. The number of columns in the first matrix has to be equal to the number of rows in the second matrix in order for this to happen. If that's the case, which it is here, then our output is going to be the number of rows in the first matrix by the number of columns in the second matrix. So in other words, the output here is going to be a 1 by 2 matrix. So let's see what we can do in order to get our answer. So let me erase what happened there. And I'm going to show you how to get those two. Let me put this back in here. I'm going to show you how to get, we'll call this row 1, column 1, and we'll call this row 1, column 2 in our answers. Okay, so for row 1, column 1, that's going to be equal to row 1 of our first matrix, which we only have 1 row, times column 1 of our second matrix. So we're going to take the 3 and we're going to multiply it by 5. And then we're going to add the next product, which would be -2 times 0. And then we're going to add 7 times -1. So now you can see why it was so important that the row number of the second matrix corresponded with the column number of the first matrix. They are both 3s, so you have exactly 3 terms in each that you can multiply together and add them. So then just doing our multiplication, we have 15 plus 0 minus 7, so this is 8. So I'm going to erase this, and I'm going to put my 8 up here. Okay, so that one's 8. Now let's look at row 1, column 2, and we're going to do the same thing. So instead of using the 5, 0, and 1, we're going to use column 2 from the second matrix, which is 1, -4, and 6. So here we go. So we're still going to use the 3, -2, and 7, but we're going to multiply them with the second column of the second matrix. So 3 times 1 plus -2 times -4. I like to use parentheses around my negatives just so it doesn't look like subtraction instead of multiplication. And then plus 7 times 6. So we have 3 plus 8 plus 42. Looks like that's 53. So let me erase this guy. And I'm going to move my 53 up here to my answer, 53. So again, we started with a 1 by 3 as our first matrix, multiplied that by a 3 by 2, and we ended up with a 1 by 2 matrix, which is our answer. This second problem is one of those problems on the Math ACT where data is provided for 2, 3, or 4 problems. And so I'm just highlighting and selecting just number 43, which is the matrix part of this compound problem. So on these problems, there's a lot of information to digest, and as you're going to see in a minute, it's really important to pick the information that you need and make sure it lines up here. So let's take a look at number 43. It says, the average number of gallons of water consumed per day by each elephant, lion, and giraffe is 55 and 10. And the question says, which of the following matrix products, so we're dealing with matrix multiplication, gives us the average total number of gallons of water consumed per day by all of those three animals in the park? So the question really is, which one of these matrix multiplications is going to give us a 1 by 1 matrix, because we are looking for one number in our answer. So knowing what we know about matrix multiplication, we can really eliminate a few of these answers off the bat. So looking at A and B, A is a 1 row by 3 column first matrix, and then a 3 row by 1 column second matrix. So this is going to give us an output of a 1 by 1 matrix. That's exactly what we want. So A is still in the running. As is B, you notice B has the same sizes of matrices. So A and B are possibilities. Let's take a look at C. C is a 3 by 1 matrix multiplied by a 1 by 3 matrix, right? There's 3 rows by 1 column, and there's 1 row by 3 columns here. So the output for C is going to be a 3 by 3 matrix. Well, that's way more information than it's asking. 43 is asking for one number. This would give us a 3 times 3 or 9 numbers as our output. We don't want that. So C is a gone as a possibility. Same with D, right? D is a 3 by 1 times 1 by 3. So D is gone too. Let's look at E. E is also starting off with the 3 by 1 matrix being multiplied by another 3 by 1 matrix. But wait a second. A 3 by 1 matrix can't be multiplied by another 3 by 1 matrix because these middle numbers aren't the same. So right away, we can eliminate that. We can't even multiply that if we tried. So E is gone as well. So yay, we're down to 2 options, A and B. Now we just need to figure out which of these 2 options is going to work for us. So if we look at these first numbers, we just need to make sure they line up correctly with the second matrix. So then we need to look at the data given to us in the problem. It looks like elephants, so I'm just going to write this down. Elephants there are 600 elephants in this park. Okay, and then lions are 200, and there are 800 giraffes. So then we need to make sure it says elephant, lion, giraffe. In problem 43, if you read the very first sentence, it says elephants consume 50 gallons of water. So I'm writing that down. Lions are 5 and giraffes are 10. So as long as these numbers are lined up, then you know you have the right matrix. So 600 goes with 50. If you look at A, that's correct. But also if you look at B, that's correct. 200 goes with 5 in part A, which is correct because that's what we have here for lions. So it looks like A is our answer. And just confirming, 800 goes with 10 for giraffes. This third problem was taken from the very last problem on a recent ACT math section. But as you'll see, as long as you understand matrix multiplication, it is not a difficult problem. In fact, this problem is very straightforward. Let's take a look. For this third problem regarding matrices, this is a matrix multiplication problem because you can see the word product. And if you look at the problem number, this was actually the last problem in the math section on a recent ACT. So usually when you get to the last few problems of the section, they're getting harder and harder. But now that you know matrix multiplication, this problem really is very easy and it doesn't take a lot of time. So I'm hoping this gives you almost a free point on the ACT math section because you're going to know matrix multiplication now. So as you remember from the mini lesson, we're dealing with a 2 by 2 matrix multiplied by another 2 by 2 matrix. So let's compare these numbers. Yes, as long as the column number in the first matrix and the row number in the second matrix are the same, which they are, this matrix multiplication is doable, and you're going to end up with your output is going to be a 2 by 2 matrix. So right off the bat, which one can we eliminate? We can eliminate G, because G is a 2 row by 1 column matrix, and we can eliminate H because H is a 1 row by 2 column matrix. So our only options left are F, J, or K. So then let's just do our first cell. Okay, so we're looking at this cell right here. So that's going to be row 1, column 1. So we're going to look at row 1 of the first matrix and column 1 of the second matrix and multiply those together using the strategy from the mini lesson. So row 1, column 1 is going to be 2 times A plus 4 times C. So right now, it looks like we have an answer. It looks like this is going to be K, because F doesn't have 4C involved in the row 1, column 1, and H has 2A plus 6B. That's not what we got. So it looks like K is our answer, so we're pretty much done. I'm just going to confirm maybe with one more. Let's do row 1, column 2, and that's going to be put right here in our final answer. So that's going to be 2B plus 4D. And if you look at K, yes, that is the same. So there's really no need to go further. You don't even have to go more than one cell. You know that K is the correct answer here. Thanks for watching. Don't forget to subscribe.